So in this chapter of gravitation, you need to know Kepler's laws of planetary motion, Newton's laws of gravitation, intensity of gravitational field, gravitational potential energy, escape velocity, all these things. I'll be explaining all topics one by one. But before we start gravitation here, let me tell you some wrong ideas people had in the ancient age. People used to think that universe is earth centric. Earth is fixed, then everything rotating about the earth. Galileo and Tycho Brahe. Galileo is the genius. He only first said about the laws of falling bodies, which we have studied in motion in one dimension, and motion under gravity in motion in one dimension, and he gave the idea of the heliocentric orbit, that is, sun is the heavenly object about which all the planets including earth is rotating.
I can't see the.
You can't see the screen. Okay, I'll be sharing it. Screen is. Oh, it was not shared. Now it is. Okay. Can you see my screen now? It's okay?
Sir, no, I can't see.
But I have shared. Then I can just log out once and then log in again.
Okay.
Oh, they're not, it is not possible to share probably. Wait a minute, let's see. Can you see it now? Hello?
Sir, no, I can't see him.
Okay. You inform me when it is visible.
Okay.
Still it is not visible, no?
Sir, I can't see him. It's not visible.
Yes. Then I stop sharing this thing. Let me do it in OneNote. Just a minute. Let me arrange it. Just a minute, let me try once more.
Yes.
Now is it visible?
Sir, no. Not visible.
Then I stop sharing this whiteboard. I am sharing different board with you. Just a minute. It is taking longer time to share. But there may be connection problem, that's why I switched off my camera. But still, if it doesn't work, check, is it visible?
Yes, it's visible.
Now it's okay, no? Because I have shared a different
Yes.
board with you. Okay, let us know what is there in your syllabus first in gravitation. Kepler's law of planetary motion, universal law of gravitation, acceleration due to gravity and its variation with altitude and depth, gravitational potential energy, gravitational potential also there, escape speed, orbital velocity of a satellite. All these things we are going to study one by one this session. Laws of gravitation was given by Newton, that every particular matter attracted towards the earth by some force which is stated by Newton, that the force is directly proportional to product of their masses and inversely proportional to square of separation. But as we need to start with the history of gravitation, so we have to study Kepler's laws of planetary motion first. Before Newton, Kepler's laws of planetary motion came into scenario, and then Newton's laws of gravitation. Kepler's laws of planetary motion, all these laws are supported by the great astronomer Tycho Brahe and his colleague Copernicus. Okay. Based on all the observations, Kepler stated planetary laws. We will learn one by one Kepler's laws of planetary motion. That is, we need to know orbit of a planet around the sun. And this is heliocentric. Sun is the central object. About the sun, a planet revolves around the sun in elliptical orbit. Let me give you the concept of elliptical orbit first, and then I will state Kepler's first law. Suppose between these two fixed points S1 and S2, the ends of a string are made fixed. Okay? The distance between S1 and S2 fixed. You don't change the position of S1 S2. So length of this string, I mean P2 S1, length of string is what? This is the string. S1 P S2 is the string, this S1 PS2 is also fixed length. This is of this length, this chord is of fixed length. Now keeping keeping these two positions fixed, I mean strings end you keep fixed here. If the point is moved in the plane of this board, in the plane of paper, then the point will describe a path which is known as elliptical path. Okay, what is the condition here? You are moving the point P in such a manner that these two ends don't move and the cord, I mean the string, is inextensible. Then it will describe an elliptical path like this. This is one half, this is the other half. It is not properly elliptical path drawn here. I tried to show you exact path, elliptical path will be like this. This is not a circle. I mean, suppose there is a circle. This circle you are stretching in such a manner that it's like this. Path will be like this. This path I wanted to draw here, this is called elliptical path. You have kept the string ends fixed at S1 and S2 and moved the point P on this path. Okay, then these 2 points S1 and S2, they are known as foci or foci of the conic. Ellipse is a conic section like circle but not exactly a circle. It has a major axis AB. It has a minor axis of length CD. And if this end is a comma 0, this end is minus a0, this is 0b, this is 0 comma minus b, then S1 and S2 are two foci, and this point O, midpoint of A and B, AB is called major axis. This is included in class 11 mathematics syllabus. Definitely most of you, those who have mathematics, they will study in class 11 mathematics only, but later. Now you have to know this elliptical path because we want to discuss Kepler's laws of planetary motion. The concept is based on this elliptical orbit. So these 2 points are foci. I told you it is heliocentric path. Sun is the central object, and objects, I mean planets, do not move about the sun in circular path. This is old concept. Ancient people assume that planets move in circular path. Actually many ideas were there, all those wrong ideas were there before Kepler. Kepler only formulated, he stated, he observed that keeping the sun at one of its foci, a planet's position is taken as P, a planet revolves around the sun in elliptical orbit. Okay, what is the first law due to Kepler? First law is this: keeping the sun at one of the foci, a planet revolves around the sun in elliptical orbit. Around the sun in an elliptical orbit. Okay, so this orbit is elliptical. These 2 points are called foci, and how ellipse can be described, that I have tried to tell you that PS1, PS2 is the length of the string, keeping ends of the string fixed at S1 and S2. We are just moving the chord in such a manner that chord is inextensible and PS1 plus PS2 remains the same, where S1, S2 are fixed. And in case of elliptical path, we have referred this one as these 2 points as foci. Foci are S1 and S2. Sun will be at this point or at this point. The planet will revolve in the elliptical path. What is the consequence of this elliptical path? You can see that if the sun is situated at S1 and planet here, then this is the maximum distance. Planet assume at P1, which coincides with A. Then P1 is at furthest away from the focus S1. It is the maximum distance between the planet and the focus, which is P1 S1, and minimum distance when the planet lies at the point B. This is the minimum distance. Okay, this concept of aphelion and perihelion you have studied before. I am not going in details. You just know this is the minimum distance between sun and planet, and this one S1 P1 is the maximum distance. Okay, so sun at the focus, planet is moving in this elliptical orbit. Minimum distance is P2 S1, maximum distance is S1 P1. All other distances are in between these two, isn't it? I mean, take an arbitrary point here, P3. That P3 S1 will lie in between these two, the maximum and the minimum distance. Now, distance of the planet from the sun varies. The consequence of first law I am going to explain. Distance of the planet from the sun varies. So it will cause the variation of seasons, and its repetition after 1 year. Season changes, it is because of this region. We feel hot when distance between sun and us, our planet Earth, is very small. I mean that minimum distance. Okay, so variation of seasons can be explained with the help of first law. Then second law. Second law is the radius vector joining the sun and the planet, you can write the statement with me, the radius vector joining the sun to the planet sweeps out equal areas in equal intervals of time. Okay? The radius vector joining the sun to the planet sweeps out equal areas in equal interval of time. Let me explain. X-axis, y-axis, elliptical path. This is a focus, this is another one. Planet, suppose today it is here. After 10 days the planet goes there from P1 to P2. This is the radius vector joining sun to planet. See, its length is changing. After 10 more days it goes to P3. Then according to Kepler's second law, this area, I mean a red region, will be equal to area of this blue region. And you must have noticed that I told about 10 days. 10 days from P1 to P2, 10 days from P2 to P3. So, per day, the description of this area will remain constant. That's why Kepler said that, he stated this way, rate of description of sectorial area is a constant. Rate of description of sectorial area is constant. That is, if it happens in time, this area, suppose this area we have taken delta A and time is delta t. Then this area, same area and time C. Or delta A1, delta T1. Then according to Kepler's law, this delta A by delta T, limit delta T tending to 0 will be limit delta T1 tending to 0, delta A1 by delta T1, it continues. This is equal to a constant. So this implies when delta T tending to 0, this is dA by dt. So this implies dA by dt equal to a constant. Okay? This Kepler's second law can be derived with the help of principle of conservation of angular momentum, which we have studied in the session where rotational mechanics we have explained. By using the principle of conservation of angular momentum, this can be proved. I am not going for the proof now, just know the law. So this law is also very important. It will help us to study the nature of the motion of planet around the sun. Okay, this rate of description of sectorial area, but you cannot say that velocity remains constant. It cannot say that this length of radius vector remains constant. No, but rate of description of sectorial area is a constant. Physicists have proved this with the help of conservation of angular momentum. External torque is absent. No, in case of planetary motion, external torque is absent. I am coming to the proof, end of the chapter. So second law is this. Third law, you know. What is third law? Third law, this planet revolves around the sun T with the time period of revolution. T with the time period of revolution. According to third law, T square is proportional to r cube. Square of time period of revolution directly proportional to the cube of length of radius vector. This is Kepler's third law. T square proportional to r cube. Suppose for a planet time period is T1, radius be r1, at any instant another planet, or this one has time period T, another planet has time period T2, radius of its path or radius vector at any instant be r2, then T1 square by r1 cube for the other planet, T2 square by r2 cube for the other planet, T3 square by r3 cube. It happens this way. That's why we can say that T square by r cube equal to a constant. This is Kepler's third law, very important. And Kepler, with the help of the observation made by Tycho Brahe and his colleague Copernicus, which I wanted to tell you, but it was not possible. Based on his observation and their observation, he formulated this law. Okay, T square proportional to r cube. And the next one which we are going to study, Kepler's law of gravitation, its derivation initially was done with the help of this concept, this Kepler's law of planetary motion. Newton's law of gravitation, let me deduce, then I will state the law. Just after this I am coming to Newton's laws of gravitation. We are going to see that the law of gravitation actually came from Kepler's law when they were thinking about the motion of planet around the sun. So again take the elliptical orbit, or better I take, for your better understanding, I take circular orbit. Let circle and ellipse, there is a difference of course. For a circle there is no major axis, no minor axis. For ellipse there is a major axis AB, there is a minor axis CD. These two are not equal. But here I am, for better understanding, I am initially assuming orbit be circular. So radius be r. Okay, let a planet whose mass is mp revolves around the sun heliocentric orbit, its radius is r. Then according to Kepler's law, time period square is what? Proportional to r cube. Now time period is what? Here T equal to 2 pi r by v. You agree? Because length of circular path is 2 pi r, that by v will give you the time period. So time period is T equal to 2 pi r by v. So T square is what? Okay, I am coming to T square. We have this one, we have this one also. Now in a circular orbit, what acceleration acts, you know, when a body moves with velocity v, then acceleration is v square by r. Then force is what? F will be mp into AC, that is mp into v square by r. Now here if you put the value, this T equal to 2 pi r by v, then it will be this thing square is proportional to r cube. So 4 pi square r square by v square is proportional to r cube. Okay. Now this r, or if you eliminate v from here, then this v square is going to be proportional to 4 pi square by r. This you can see. So v square is nothing but k into 4 pi square by r. I am going to give you the mathematical idea from where they are encouraged to establish Newton's law of gravitation. Correct. Then F going to be what? F is equal to mp into k into 4 pi square. R is already there, it is r square. Okay, so this 4 pi square into k mp by r square. Then it was assumed that 4 pi square k is proportional to the central mass. This constant, they assume that 4 pi square k is proportional to the central mass. This is not pure constant, that manner. So V will be equal to what? It is proportional to mp into ms by r square, or you can change this one as 4 pi square k is equal to g into ms. So force going to be what? From here it is g ms mp by r square, and this is Newton's law of gravitation. I wanted to tell you the mathematical background which helped scientists initially to state the law. Okay, law definitely based on the practical observations. They had performed the experiment that really the force directly proportional to product of masses and inversely proportional to square of separation, but mathematical base also there. By using Kepler's third law, we can prove. You'll just write, if you want to derive this manner, it is observed that it is observed that 4 pi square k proportional to the central mass. Okay, proportional to ms. So 4 pi square k gms, put it there, coming Newton's law of gravitation. So before Newton, people are there. Newton got great idea, definitely, but before him also Kepler gave the idea of this laws of gravitation that can be derived this manner. Newton finally stated this in the form of law. So what are the laws of gravitation? This is important to understand. Laws of gravitation. It is not a very strong force like electric force, but this force exists. This force has very high importance in physics because it can act between two bodies separated by the least distance as well as between two objects separated by the largest possible distance. So this law holds good for two nucleons. In a nucleus, you know that proton is there, neutron is there, okay, many protons, many neutrons may be there, force of gravity exists there, and force of gravity exists between this mass and sun also, although magnitude is very small, but it exists. So this is universal law of gravitation. We can state this one as universal laws of gravitation. What is that? This is attractive only. Force is attractive, no repulsive force is there. The force of attraction, don't say or repulsion, it is attraction only. The force of attraction between two stationary masses is directly proportional to the product of masses and inversely proportional to the square of distance of separation. So I am just coming out of that motion of planet around the sun. I am stating it in terms of any two masses. This is mass m1, mass m2. They are separated by distance r. The force directly proportional to m1 m2, force inversely proportional to square of separation. This is Newton's law. Combining 1 and 2, what do you get from 1 and 2? That F will be proportional to m1 m2 by r square. F is proportional to m1 m2 by r square. Therefore, F equal to G m1 m2 by r square. This G is called universal gravitational constant. Okay, this is laws of gravitation. If nothing to understand there, this is a force. Force is a vector quantity. So force of force of gravity also a vector quantity, as force is a vector quantity. So let me explain 2-3 small examples to understand this nature of this force. So what nature you have studied, that I am noticing here, that I am writing here. Notes. Number 1, force of gravity is attractive only. Okay, this force of gravity is a central force. Why central force? Because it acts along the line segment joining two only. This you can keep in your note. Why central force? As it acts along the line segment joining two masses. As it acts along the line segment joining the masses only. Clear? It acts along the line segment joining the two masses. That's why it is called central force. It is attractive only. And third point, principle of superposition can be used. Clear? So these two masses m1 m2 there, force will act along this. m2 will be experiencing force this manner, m1 will be experiencing force this manner, nothing else. It cannot go this manner in this direction. Force is not this direction or not in this direction. These are wrong directions. Never. It is central force. It is attractive only. It obeys the superposition. Principle of superposition can be used. Let me explain what is principle of superposition. Then I will be showing you some numerical problems. Suppose many objects are there. Okay, they have masses. And right now they are particles. Those particles have masses m1, m2. In this way, many masses are there. This is mi, this is mn, something like that. Okay. Suppose I am considering force between this mi and m2. Their distance be equal to r. Distance between them be equal to r. Then force will be what? m2 mi, that we have written proportionality G also, no? G's value I did not say, universal gravitational constant I will tell you. So here the force is G into m2 mi by Ri square. Ri is the distance. If equal to this, will you say that this force will affect or affected by the force between mi and m3? There is a force also. Am I experiencing force this manner? M2 Am I this way towards m3 and this mi towards m2 also. So this is direction of force and this is also direction of force. You will see that so many forces are acting. What's the use of giving mi so much preference? Because I am considering force between mi and m2, then I'll ignore the presence of other masses in the surrounding. Then what will the net force experienced by mi? This will be vector sum of all the forces it experiences due to each individual mass. Let me write the principle of superposition. And we'll solve problem also based on it. So force of attraction between two stationary masses is not dependent on the presence of other masses in their surrounding. Is not dependent on the presence of other masses in their surroundings. Okay. Net force experienced by mass. Then what about net force? You cannot ignore these forces also. So what's the net force it experiences? This mi mass, it is vector sum of this Fi3, this Fi2, this Fi1 and this Fin. Okay. So net force experienced by a mass, net force experienced by a mass is the vector sum of all the forces it experiences due to each individual mass. Let us work on it. Okay, but with short example. Later on we will do tricky sums, good sums. Don't say tricky sums. The problem is this: three masses mh are situated at three vertices of equilateral triangle of side length A. Then question is, these points be A, B and C. Question number 1, what is the force experienced by particle at M due to these two particles? This is question number 1. Find the force of gravity on B. Achha, one thing, you go back to laws of gravitation. You did not ask me why it is called Universal Law of Gravitation. This let me explain, because many questions will arise. Those who think about physics, those who want to do everything by understanding only, it matters for them. Why it is universal? The laws are universal as the force is independent of the medium between two masses. Okay? As the force is independent of the medium between two masses, or surrounding medium, that also you can say, medium and surrounding medium between two masses. It is independent of physical condition. It is independent of physical condition of the surrounding. It acts between two masses separated by the least possible distance as well as between it acts between two masses separated by the smallest or least possible distance as well as between two heavy objects. Heavy object means planet and sun, between two planets. Heavy objects separated by the maximum distance. Okay? It acts between two masses separated by the least possible distance as well as between two heavy objects separated by the smallest possible distance. Why did I say here? The law is universal, that's why. Here also, before you apply it, when everything is done, you have learned little bit of weak force, strong force, electromagnetic force and gravitational force. Everything will be mixed up. There, in case of electric force, force very much dependent on the medium, but gravity is independent of the medium. Okay, so that is first thing. Second thing, I want to find the force of gravity on B. That gravity acts between any two masses. There is gravity between B and A. You agree? There is the force of gravity between B and A. B will experience force towards A. B will experience force towards C. This force is FBA. This force is FBC. Okay? Force of gravity, I remind you, G m1 m2 by r square. R is A here. Distance between these two particles is r. Okay? So r is equal to A. m1 m2 equal to, both are equal to m. So force of gravity on B is found out, that FBA is equal to, FBA equal to what? Force experienced by B due to A, it is Gm square by r square, because m1 m2 same equal to m, we have assumed, r square. R square is A square. Clear? So force experienced by particle of mass m at B due to mass at A, we got. What is FBC? That also exists. FBC. Force experienced by B due to C, particle at B due to particle at C. This is also Gm square by A square. In what direction? That is along BC. Clear? So now resultant force will be vector sum of these two. So if resultant, we have to find. We have used principle of superposition. We found FBA and FBC, but resultant force neither along BA nor along BC. It will be along the bisector. Why? Because these two are equal. What is the vertical angle? 30 degree. This is also 30 degree. So you find the resultant of these two. FR equal to what? This plus 2 into FR square. FBA, FBC cosine 60 degree. FBA we got Gm square by FBA done, FBC also done the same manner, whole square plus 2 Gm square by A square into, just combine all these things, cos 60 is half. So this Gm square by A square coming 3 times. So FR is going to be root 3 into G m square by A square. Clear? This way you can get a resultant. Resultant of two forces. The force of gravity on this mass is resultant of these two. Is it okay?
Yes, sir.
Now we are going to discuss the acceleration due to gravity. Let us do it. Today's class mainly theory. You know your syllabus first. Huh?
Yes.
Acceleration due to gravity. Gravity, acceleration due to gravity. Gravity is between the earth and an object situated on the surface of the earth. This is the earth. The earth. Mass m situated here. Earth's mass, it is a solid object. It is concentrated at the center of the earth. Okay? Now assume that distance between this mass and Earth's mass be smaller. This one, the radius bigger. This one, let it be equal to h. So small r going to be what? H plus r. Clear? So object is at height h above the earth's surface. From center it is smaller, which is r plus h. Now this object is attracted towards center of earth due to gravity. What force will be acting between the mass and the earth's mass? I am writing Fg. This is nothing but Gmm by r square. Force of gravity is Gmm by r square. Now, what is the acceleration acting on this mass? Acceleration will be what? Earth will not move. Because the Earth's mass is large, its acceleration is very small. So, acceleration of m's mass towards the Earth, it means towards the Earth center. Acceleration of m towards the center of the Earth is given by Fg divided by m. This is nothing but Gm by r square. So this G at that height h is nothing but Gm by r plus h whole square. This is number 1 and this is number 2. This is acceleration due to gravity above the Earth's surface. Okay? Now, this acceleration due to gravity on the surface of the Earth is what? We often use this one, 10, 9.8, all those things. So, let us account for this. On the Earth's surface, of the Earth, h equal to 0. So G, this we take G only, not GH. This G surface we are writing simply G on the surface. It is Gm by r square. Big G value I haven't told you yet. I will be telling you now. Big G has the value 6.67. It is very close value. 6.67 10 to the power minus 11 SI unit. I mean that in terms of force you can write F equal to that G mm by r square. So unit if you want to say, it will be Newton meter square by kg square G. Okay, so SI unit I have written. So on the surface, whatever you got, that you take as number 3. At height h, what you have got? Okay, before doing that, let us find the value of g. So put g equal to this. Earth's radius approximately 6400 kilometer. This is 6400 10 to the power 3 meter, and am equal to Earth's mass. Earth's mass I can tell you, just wait for that. Mass of the Earth. We need to put the value over there, mass of the Earth. If we put, then you will get the value of acceleration due to gravity on the Earth's surface. It is 5.98 into 10 to the power 24 kg. We are just imagine that the values are taken over there. So by putting this value, g will be a big G. Put now. But all of you will write in exam what? You will not calculate. No one calculates in this world such a huge value. G, m1, m2, gm by r square. So it is 5.98 into this divided by whole square. This is approximately 9.80 meter per second square. Sometimes we take 10 meter per second square if mentioned. Otherwise 9.80 is the closest approach of the actual value. Clear? Now let us compare 2 and 3. Gh by g, if we calculate, it will be gm by r plus h whole square, gm by r square. Okay? So this implies g into r square by r plus h whole square. This is the actual relation. Should remember this thing. At a height, if you want to find, that height must be known, radius of Earth standard, value of g on the Earth surface standard, that is 9.8, and you can find the value of acceleration due to gravity at some height above the Earth's surface. Now, some cases the distance, height above the Earth's surface is comparable to the Earth's radius. In that case, when it is comparable, then we don't change the formula. But for small height above the Earth's surface, we can approximate it. How to approximate, that I am showing you. For small height above the surface of the Earth, gh is g into r square. From here you take r square common. R common means r square common. R common inside bracket. Clear? So taken r as common there. So what did you get? R square, they get cancelled. So gh will be g into h by r to the power minus 2. Clear? So this is acceleration due to gravity above the Earth's surface, but we can approximate. How? Binomial expansion. For small values of x in the expansion of 1 plus x to the power n, we can write this is approximately 1 plus nx. For what values of small x? For small values of x, we neglect higher powers of x. Okay, we write 1 plus x to the power n approximately 1 plus nx. So gh is g into 1 minus 2h by r. Clear? This is your number 5. So if x is small, it means here x is what? Here small means what? That h by r is very, very small. Why do you get h by r very, very small? That is above the Earth's surface, just very close to the Earth's surface, h by r is very, very small. This is r. This part h, this height is very small in compared to r. In that case, this approximated relation you can use. Okay. So this relation valid for heights comparable to r, and this is valid for heights very, very smaller than r, just above the Earth's surface. 200, 300, 400 meter, you apply this. Okay, this is valid for this relation. Now in both the cases, we can make one observation, very important observation. What is that? Observations that gh by g r square, this is the original relation, numerator heavier than denominator, this is smaller than 1. Am I correct? Because some h is there which is positive. So this implies gh smaller than g. So what will you write? So acceleration due to gravity decreases with height. Clear? gh is smaller than g. Acceleration due to gravity decreases with height. So if you go up, acceleration due to gravity decreases. Now can't I say that weight of body also decreases? You multiply by m. m into gh less than h. So weight of a body, of an object, reduces with height. It's clear? Weight of an object also reduces with height. Now just write one numerical, solve it. I'll give you 1 minute time. Just write at what height above the Earth's surface, weight of an object reduced to 1/16th of its weight on the Earth's surface. I read, at what height above the Earth's surface weight of an object reduced to 1/16th of its weight on the surface. At what height? Should I use this relation, this one or this one? You think and then answer accordingly. Number 4 or number 5. When something unknown is there, when you don't know that height is at very small distance above the Earth's surface, then to be safe sided, use number 4. This is the general relation. So let us start with this. At a height h, let us answer this question. Answer. At height h, above the Earth's surface, gh equal to gr square by r plus h whole square. Now multiply by m. mgh equal to after this you can do. Just read the question and then answer. Just read. Weight of body reduced to 1/16th of its weight on the Earth's surface. Done. As mgh equal to mg by 16, it's given 1/16 of its weight. So this implies r square by r plus h whole square. So take square root. Therefore, so h is equal to 3r. The object will be taken at a height h above the Earth's surface, which is 3 times the radius. So here the relation that which is valid for small height automatically will not work, isn't it? This relation you got, it will not work. When it is unknown, you apply this formula. Okay? So at a height 3r, 3r means 3 into 6400 kilometer above the Earth's surface, weight becomes 1/64th. So what we have studied? We have studied acceleration due to gravity and its variation with height. We have studied. With height, how does it change? Let us know variation of G with depth. Now, before we do that, I have to tell you some very important observations from laws of gravitation. When I am considering, in the previous example already I have considered that with solid sphere, Earth's shape we have considered almost a sphere. It's a sphere, mass concentrated at the center of mass. So force we have considered that gmm by r square, it is central force. It will act along the line segment joining the bigger mass and the smaller mass. If somebody asked you question on this hollow sphere and the mass m, in what direction the force will act? Here also you can assume that the mass of the spherical object concentrated at the center, and the force of gravity will be what? Between small m and big M, it will be gmm by r square. Okay? This force of gravity will be gmm by r square. Why? Because I just show you one observation, then you keep in the form of note. Take a small mass here and this mass. This smaller one will experience force this way. It has component this manner. Take another mass here, just symmetrically opposite or vertically opposite or diametrically opposite. Due to this mass, it will experience force this way. A component will be acting this manner. What about the other component? The other component here this way, for this mass this way. And they get cancelled. These two forces get cancelled because they are equally opposite. So force M will be acting towards the center only. So if M experiences force towards center of the hollow sphere also will experience force towards smaller mass. So force between these two objects, small m and big M, always will be in this direction. There is no question about it. Why? That I have explained with the help of gravitational force and concept of vector. Okay, this one thing you should remember. Force is central. This is for hollow sphere also. A very important observation, that force between a hollow sphere and a small object also act along the line segment joining the center of the object. Force between hollow sphere and M outside and mass M outside the sphere will be directed along the line segment joining two masses. Okay, this will be along the line segment joining two masses. line segment joining the mass and the center of the sphere. Joining this point mass outside, joining the mass M and the center of the sphere. Clear? Never forget this. Never do any mistake in this regard. The second observation, if the mass lies inside this M and mass lies here, this is very important, very interesting, but proof I am unable to give you because a mathematical concept is there. Proof is not required, just remember, there is, in this case, there is no force between small m and m if m lies inside. Please don't forget, very important concept. Okay, now let us do this thing, variation of G with depth. Let us draw Earth. The Earth, this is Earth, solid sphere, not ring. Center of the Earth, a point is taken at A, mass m, radius of this is Earth. When you take the mass at height, on the surface, then Earth's mass concentrated here. So at a point on the surface, F you know G mm by R square, and F by m we have calculated before, Gm by R square, R means big R, and this is approximately 9.8 or 10, whatever you take. Both are approximate. Exact value though we don't know because it changes with position. Approximately that. Now this mass is taken at a depth d below the Earth's surface. Okay, this is Earth. Black color is color of the Earth is black. Only boundary taken the yellow color. Now at depth d, you draw the Earth again, but smaller size. This ring you are drawing. A ring, no, this is also a sphere. That sphere through the point P you have drawn. Center remains the same. The particle of mass m you have taken at this depth d below the Earth's surface. So this is what? R minus d, distance between mass and the Earth's center is R minus d. Just I told you, inside sphere if anything lies, no force. So when you have taken the mass m at a depth d below the Earth's surface, the force will be between at the depth d below the Earth's surface force of gravity is in between small m, the mass, and the portion of the earth of radius r minus d. Try to understand what he told. Because this portion, this portion has no effect on him. It is due to this inner sphere only, r minus d. So the force of gravity is going to be what? And acceleration due to gravity at that depth be gd. So F will be what? M into gd. This is g m by r minus d whole square. I am wrong here. Whole mass you cannot take. This is m dashed. Okay? This is m dashed. Here this equation you take on the surface gm by r square as number 1, and this equation you take as number 2. Clear? Now this m dashed we have to write m dash, this m dash, this mass is m dashed. Total mass of the earth is m. This m is the total mass of the earth. That is equal to m. This one m dashed. This mass is m dashed. This one has mass m. We have to find m dashed. Assuming the earth is a uniform sphere, uniform density rho equal to m by 4/3 pi r cube, m dashed will be what? 4/3 pi r minus d whole cube into rho. I am waiting. You first understand what I did, then I will proceed. Is it okay? This is okay? You understood? Hello? It's okay, no? So let us proceed.
Yes.
So m dash we got here. Just put this value of m dash there. Then we'll be comparing this GD. GD we got. This GD equal to gm dashed by r minus d whole square. So we have to compare whether increased or decreased, that I want to see. Now from 1 and 2, GD by G equal to what? Just divide. Okay? Put the value here. G r square by r minus d whole square into m dashed by m. M dashed you put 4/3 pi into rho, and mass of earth is what? 4/3 pi r cube into rho. So strike it which is common. R square get cancelled, rho get cancelled. So this is just a minute. Just a minute. This is G, we have divided GD by G. Gm dashed by r minus d whole square, Gm by r square. You forgot to write, I forgot to write G. G also strike out. So what is left over there? There is r minus d1 in the numerator because get cancelled. In full just r minus d left, and here r is left. So GD equal to G1 minus d by r, isn't it? So what do you observe? At a depth d, the acceleration due to gravity is reduced. GD equal to, here you got GD equal to G into 1 minus r by d, isn't it? After cancelling, GD equal to G into, sorry, not r by d, it is d by r. So at a depth d, when you are taking the acceleration due to gravity, takes this form. So GD by G is what? 1 minus d by r. It is less than 1. So GD equal to G into 1 minus d by r. Clear? You understand?
Yes.
GD is G into 1 minus d by r. And this decreases with depth. Therefore, GD decreases with depth. So, acceleration due to gravity or weight of an object reduces with depth. Just one homework you write. This is very important for your school-based examination. This is the only work I'll tell you to do. Explain graphically how G varies with number 1 height, number 2 depth. Only this work you will try. I'll check and then I'll tell you whether you are correct or wrong, and then I'll tell you the proper method of explanation. Okay? So I hope you have understood the change of gravity with height and change of gravity with depth. Now we are going to find the expression for gravitational potential energy. Okay? Gravitational potential energy. Potential energy we have done already. Potential energy chapter we have done. Potential potential energy between two particles. If two particles here separated by some distance, say m1 and m2, they are separated by distance r. Okay, these two are separated by distance r. If you want to remove, before you start gravitational P, if you want to remove m2 from m1, then you have to do work. So if you want to bring the mass from some reference point to m2, then also you have to work. Question is, how much is the work and what is the concept? Let us make this effort. There is force of gravity. This is experiencing, you know, F12. This is experiencing F21. And I want to separate M2 from M1 at infinite separation. I want to remove M2 at infinity. I want to take M2 at infinity. So myself is the external agent, has to work against the force of gravity. At this distance, force of gravity, you know, it is F equal to G m1 m2 by r square. Now, if I want to remove it to infinite separation, then this x separation between arbitrary position of m2 and fixed position of m1 changes. X changes. So when distance x, force of gravity is what? G m1 m2 by x square. This is a variable force. X changes. This implies F also changes. Okay? So, if we want to move it further by distance, I am the external agent, I am moving it by distance dx. Force of gravity acting this way. You are giving displacement opposite to it. See how much work I am doing. Account for this. To give a small displacement dx. This displacement is by dx. Work done. Small work done. dW equal to force of gravity into dx, you know. But this is dot product. This is against the force of gravity. So, it is F dx cos 180. Put the value of F over there. Just put F over there. So, dW is what? G m1 m2 by x square dx into minus 1 minus g m1 m2 by x square into dx. Now, we are going to find the work done to remove the mass m2 into infinity. to find the work done to remove the mass m2 into infinity. I am doing the work and I have to account for this. Because force is changing, I have to give small displacement and then account for the total work done. So total work done to remove at infinity is W minus gm1 m2 by x square dx. Initial separation was r to infinity. So integrate this minus gm1 m2 x to the power minus 2 dx r to infinity. So W equal to gm1 m2 x to the power minus 2 is what? Minus 2 plus 1 r to infinity. gm1 m2, this is infinity. Something by infinity is 0. So W equal to minus 1 by infinity plus 1 by r. Isn't it? Upper limit minus lower limit. Check. Work done to remove the mass from its position to infinity is how much? W equal to minus gm1 m2 by r. Clear? To infinity. Work done to remove the mass into infinity is this minus gm1 m2 by r. Now gravitational P you can define this way: the external agent taking from that to infinity, or from some reference point infinity to the point how much work is done, that you can take gravitational P between two masses m1 and m2. If they are separated by distance m1 and m2, to take m2 from infinity means they are at that point the potential energy is 0. Here some potential energy exists, that is minus gm1 m2 by r. This work done will be referred as GPE, gravitational potential energy between two masses m1 m2 separated by distance r, is given by U equal to minus gm1 m2 by r. In the next class I will be explaining from another point of view how this U can be defined. Today is up to this. Go for solving some numerical problems based on it. Next class, just little bit of this thing is left where I will discuss escape velocity, and this concept I will be explaining from